Are ya ready, kids?
Aye, aye, Evan.
I can't hear you.
Aye, Evan.
Oh! Who's at Iowa State University?
Evan, the calc teacher.
Good at explaining mathy things, is he?
Evan, the calc teacher.
Who's the instructor who fulfills all your wish?
Evan, the calc teacher.
So watch this video and make the final swish.
Evan, the calc teacher.
Evan, the calc teacher. Evan, the calc teacher. Evan, the calc teacher. Evan, the calc teacher. Hello again, and welcome to week 2 of final review. That was rhyming when I wasn't trying, by the way. As always, we're just going to go through problems 1 through 4 on practice final exam 3. Spell. So hopefully between the 2 final exams last week, things were starting to click. Put the 3 in there. Things were starting to click. You get an idea of what sorts of problems are going to show up on the final exam. I'm going to be a little bit mean in general because I don't want you to just be able to Google answers. But I think what I put on the final exam will be a good interpolation of what you see here. So let's just get right into it again on problem 1. Just like before, problem 1 deals with derivative rules. So product, chain, quotient, and of course the power rule if that comes up, and other ones. So let's read the problem and see if we can decide which derivative rules we're going to have to use. Problem says Q, this is really Q1 here, says d dx of the natural log of the absolute value of f of x, g of x divided by h of x. It's basically asking us, what is this equal to? So let's just start out by saying which rules we need. So as before, if I see any parentheses, equals chain rule. Quotients, of course, are quotients. Duh. And products are products. Duh. Okay, so what do we have here? Do we have parentheses? We do, and I'm not talking about the parentheses g of x and h of x parentheses. I'm really talking about the absolute value is really a parenthesis. So that absolute value sign is really parentheses in natural log problems. And really in all cases, you want to think about that as parentheses. So we have these, so I'm going to circle those. And the other question is, do we have quotients? Yes, we have quotients as well, so I'll circle those. Obviously, g, I did it again. G of x over h of x is a quotient. So there you go. So we have both a quotient and a parentheses. The real question is, do we have products? No, no products. None because, you know, this is something you want to get used to, but the fact that there's no, like the natural log of something is not natural log times something. It is a function itself. Right, so you don't talk about like, when I say f of g of x, that's not f of x times g of x, right? They're two different things. I talked about this last week when we were talking about these problems. You just want to be careful in knowing the difference between function composition and function multiplication. You have an extra x for every function multiplication you have, but you don't have an extra x for function composition. And then another thing I'm going to mention here is we use the rules from outside in. Oops. Outside in. So in this case, what do we run in first from the outside is the absolute value sign. So we have chain rule first. And then second is our quotient rule. So let's do that. d dx, natural log g of x over h of x. I'm going to actually rewrite this in terms of primes because I think it starts to make more sense when we write it in terms of primes. I'm going to put a prime there. Derivative of the outside is 1 over g of x over h of x. This is really derivative outside, keep the inside the same here. And then we multiply by the derivative of the inside, which I'm just going to leave that as g of x over h of x prime for now. So this is the derivative of the inside part, multiplied by derivative of the inside. And so when we multiply by the derivative of the inside, that's where the chain rule is going to come into play. So I'm just going to rewrite this first part out as is. And then the quotient rule. The quotient rule here is going to be bottom d top minus top d bottom all over the bottom squared. Okay, and now we just want to simplify to hopefully get it to look like the problem actually gave us the answer. All right, so how can I make this cancel correctly? Well, I'm just going to distribute. I'm going to distribute this, the first piece to the rest. So when I distribute, it becomes h of x, g prime of x minus g of x, h prime of x, and then the bottom becomes really this h here. I'm going to circle it. This h there cancels with one of those two h's there. So that's how I'll write it. So that cancels with the 2, and I really get gx hx on the bottom. And you'll notice if I split this up now, I have h of x, g prime of x, divided by g of x, h prime of x, or sorry, g of x, h of x, minus g of x, h prime of x, divided by g of x, h of x, and the right things cancel, namely the Oops, didn't mean to do that. Namely the h there and the g's here, and we get exactly the answer the PDF gives us, which is g prime of x divided by g of x minus h prime of x divided by h of x. This is the answer the exam gives. Great. Now is the point in time that you are always waiting for, because it's the point in time when I tell you this problem gets way easier if you simplify right away. So how does the problem get easier if you simplify right away? I'm going to write it out like this. Natural log g of x over h of x prime. But by our log rules, this is the natural log of g of x minus the natural log of h of x prime. And we really like how the primes behave. The derivative behaves with the minus sign there. So the natural log of g of x prime minus the natural log of h of x prime, which is exactly our answer. G prime of x over g of x minus h prime of x over h of x. And of course, the last two pieces here come from, this is either chain rule or like what you would call the general log rule at the top of the screen or the top of the exam. So either one works, but you get the same answer. So that's just something to keep in mind once again. I like to put these questions on where your life gets easier if you simplify first. All right, the next problem, which is Q2 of problem 1 actually, is DDR of the square root e to the r plus s plus t. And just as before, I'm going to rewrite this just a little bit before we try to take our derivative. Everybody definitely agrees with me here that we should rewrite a square root as a 1/2 power. So this is chain rule. And that's all it is, right? It's chain rule. Since parentheses. But I'm going to add an extra set of parentheses here just so you guys don't forget that, you have to do the chain rule there as well. Okay. So, here's a special thing. I'm not going to use primes because DDR is there the whole time. So I'll say I don't want to use notation because I want to remember if I can spell remember. These are derivatives with r as our variable. That's a special thing here. So that's why I don't want to use prime notation. I'm going to keep it as DDR. But let's use the chain rule here. Derivative of the outside is 1/2. Keep the inside the same. Or derivative of the outside is that, right? It's the power changes to a minus 1/2. Keep the inside the same. Multiply by the derivative of the inside. E to the r plus s plus t. And so I'll just mark this out in our lovely chain rule notation that we love. Derivative outside. And then the next piece is what I was going to write there. Multiply by the derivative of the inside. Okay. So what is the derivative of the inside then? Well, I'll just rewrite the whole thing, right? E to the r plus s plus t to the 1/2. That's a minus sign. All right. ddr there, derivative of the outside is e to the r plus s plus t, multiplied by the derivative of the inside. This is really dr of r plus s plus t. And for those of you who haven't quite figured this out yet, this term equals 1 because ddr of r equals 1, ddr of s is the same as ddr of t is 0 because we consider them numbers. Like 6. 6 is a good number. Okay, so that's actually equal to 1. And so what do we get as our answer? We get 1/2 e to the r plus s plus t to the minus 1/2 times e to the r plus s plus t. So what happens there is this doesn't quite look like our answer yet, but we notice that by power exponential rules, right? This is to the first power, so we can add the powers. What is 1 minus 1/2? So this becomes 1/2 e to the r plus s plus t to the 1/2, or really just 1/2 of what we started with. 1/2 square root e to the r plus s plus t. This is the answer the exam gave. So there you go. And now I have to bring it to your attention. You guys are going to hate me. You guys will hate me forever because of this. So I have to bring it to your attention. This problem gets easier. Could be way easier. If, now what is the answer? You simplify first. I cannot stress this enough, you guys. This is like the one thing that you learn in math that will save your life. Simplify every problem before you start. So let's do it. dr square root e to the r plus s plus t. Well, we already kind of did simplify this, right? We wrote it like this. R plus s plus t to the 1/2. But from there, you can simplify it one more time. ddr, exponential rules, let you pull the 1/2 down. This is r over 2 plus s over 2 plus t over 2. Or however you want to write r plus s plus t over 2 on the inside. So that's what exponential rules allow us to do. That can come inside. And then from this point, it's simply a single chain rule, right? Single chain rule. So the single chain rule equals derivative of the outside, leave the inside the same. Derivative of e is your outside, right? So derivative of e stays as e, r over 2 plus s over 2 plus t over 2, multiplied by the derivative of the inside, ddr, r over 2 plus s over 2 plus t over 2. Well, this is just 1/2 for the same reason as the other one was 1. Right, s over 2 and t over 2 are just numbers. So that equals 1/2 there. And all of a sudden we end up with the same answer, 1/2, e to the r over 2 plus s over 2 plus t over 2. But what are all of those things over 2? This is really 1/2. The same reason that we did in the forwards direction, r plus s plus t, exponential rules tell us that we can take that out as a square root. Once again, the answer, same as above. So there is question number 1, or really problem number 1. Here's problem 2. Problem 2, of course, we're doing integration. Question 1 here. What is the integral of s t to the s minus 1 divided by t to the s dt? Well, we always have choices, right? Integration problems. You always either choose u sub, which is certainly more common, or you choose integration by parts. And if the first doesn't work, go to the second. I'll say that over here. Try the second, and vice versa. Like, you don't have to be afraid of trying something and it not working out. You can always do something, do the other way later. Okay, so let's try u sub. What are our priorities here? 1 is the natural log, if it exists. It does not. 2 is denominator, if it exists. And it does. So we're going to let u equal, what is our denominator? It's t to the s. And then, I mean, the important thing here, maybe I'll write a note. dt means t, not s, is our variable. And s is just a number. That's what every single time you see d of a variable, that's telling you what your variable is for the problem. So here when I say u is t to the s and then du, I'm taking the derivative with respect to t. T is the variable. And what's that going to give here? That's going to give it's the power rule, right? So like x to the n, x squared, whatever, if the base of the exponent is the variable, that's when you use the power rule. This is s t to the s minus 1. This is the power rule. dt, of course. Okay. Do we have both u and du in our integral? Yes, we do. So the integral, so really we don't have to do anything with the du equation, and then the integral s t to the s minus 1 over t dt equals the integral. This piece is du, and this piece is u. So this becomes 1 over u, this was t to the s, remember, 1 over u du. That'll be a natural log of u plus c, also known as natural log t to the s plus c. And some of you are looking at this and saying that's not the answer that the problem gives. And it's not, because by log rules, I can't stress these other rules enough. This is s natural log of t plus c. This is the answer the exam gives. And you guys are asking me, Evan, is there a way to simplify this problem to make it easier? Before we start. Yes, there is. Woohoo! You guys are catching on. Integral st to the s minus 1 divided by t. Since t is the variable and s is a number, I can bring the s out front. Right? So that's just a number. So it can come out front. And then what's going on here is we can use exponent rules, right? EXP rules. What does that give us? That gives us s integral 1 divided by t dt. Because what is s minus 1, right? It's s minus parentheses s minus 1, which is really s minus s. Cancel each other, plus 1 when you distribute the minus sign. This becomes 1 over t. And so what is our integral? Well, that's really easy right there. Now this is just s natural log t plus c. Voila. Viola. There you go. So just, you know what? It's quite likely that a lot of the problems can get easier if you simplify them first. Let's do question 2 on problem 2. Question 2 is looking for the integral f prime of g of x, g prime of x divided by f of g of x squared dx. And this just looks god-awful, doesn't it? Awful. It looks so bad right now. It's not. Just trust me. The reason why it's not is because let's just follow basically what I'm saying up here. Follow what we do for integration problems. You choose u sub or integration by parts, and u sub is more common. So for most integration problems, we use u sub. So we'll try it. And what's going on here then? Let's follow priorities. One, natural log, if it exists. it does not, to denominator if it exists, which it does. So let u equal f of g of x squared. Then du is, okay, this is a chain rule, right? This is a chain rule problem. Chain rule 2, there's really an extra parenthesis sitting around 2 f of g of x to the first power times, this is a derivative of the outside, leave the inside the same, outside, leave inside the same, multiplied by the derivative of the inside was that's f of g of x prime. Let's rewrite that one more time. 2 f of g of x. What is f of g of x prime? Well, I'm just going to markate this out here. This is multiplied by derivative inside. F of g of x prime is a chain rule. Derivative of the outside, f prime, leave the inside the same, g of x, multiply by the derivative of the inside, g prime of x. So there you go. Oh, I seem to have maybe forgotten one piece here. Yes, I forgot one piece here. It'll be fixed when I upload things. I forgot to write it out. So this piece was, the top was supposed to be f of g of x times that. All right, all better. It's right on the PDF. I just copied it down wrong. Okay. There you go. So this is one more time of the u substitution. This is derivative of the outside, leave the inside the same. Or one more time of the chain rule. And then multiply by derivative of the inside. Cool. So now, and then there's always dx at the end of the du's. So now, do we have both u and du in our problem? Almost. But we're missing the 2. Out front. So really we're going to rewrite du as du over 2 equals f of g of x, f prime of g of x, and g prime of x dx, and this is in the integral. And so it turns this problem into integral, well, I'll rewrite the whole thing out, f of g of x, f prime of g of x, g prime of x, divided by f of g of x squared. I'll get rid of that piece up front. There we go. Dx equals, really this is 1 over u squared du over 2, so 1/2 integral u to the negative 2 du, and that brings us to negative 1/2 u to the negative 1 plus c, also known as negative 1/2. What was u? U was f of g of x squared. So f of g of x squared is g of x to the negative 2. Did I do that right? Ah, that's not u squared. That is just u. Sorry. Yes, that is just u. So this is natural log. My bad. I was wondering why I wasn't getting what the sheet had given us. So this is u to the negative 1. This is 1/2 natural log f of g of x. Sorry. Natural log of u plus c equals 1/2 natural log f of g of x squared plus c gives us natural log f of g of x plus c. And this is the answer the exam gives. You say, Evan, could we have simplified this? Yes, a bit. You could have written it as here, when I have f of g of x squared on the bottom, you could have canceled that f of g of x with one of these. So it would have ended up being f prime of g of x, g prime of x divided by f of g of x. That would have made your life a little bit easier. Same u sub of the denominator. Would bring this to integral 1 over u du, which would be natural log of u plus c, which would be exactly what we got before. Natural log f of g of x plus c. Either one works. I've been on this natural log kick lately. I'll try to dip away from it for the next final exam. I don't mean to always do it. It's just like they're good problems, so that's probably why. Anyway, don't expect all natural log integral problems on your exam, because it won't be the case. I'll make sure about that at least one of them is not natural log. Okay, problem 3. We're working on implicit differentiation. Implicit differentiation problem, the actual question asks, suppose we're going to let a squared plus b squared equal 2a plus 1b. Question asks, find dA over dB. Well, this is relatively straightforward. You just perform implicit differentiation. Follow implicit differentiation steps. See last week. Final reviews. I cover the steps in both of them, so I'll just write down me going through the steps now. So step 1 is take d of everything, both sides. So here we go, d of a squared plus b squared equals 2d of 2a plus 1b. Okay, on the left side, this becomes d of a squared plus d of b squared. And on the right side, this becomes 2. I'm going to write this out in separate C's. This is a product rule over here. I'll say that. It's a product rule. So it's a product of variables. Product rule. So we're going to use the product rule. This is 2. This is really d of a plus 1 b plus a plus 1 db. And those are way too many parentheses, but we're just going to work with it, and then it'll make sense. Over here on the left-hand side, I'm getting 2a dA. I'm getting plus 2b dB. Remember, these come from the chain rule slash what did we take a derivative of? What variable had a derivative taken? They tell us which variable we took a derivative of. Over here on this side, this is really 2 dA plus 1. dA stays as dA. Plus 1 is just a constant. It goes to 0. And then we multiply by b. Make sure we know that that's separate. And then on the other side, we get plus a plus 1 dB. Maybe I'll write this out one more way where it looks a little bit prettier for us to actually work with. 2b dB equals 2b dA plus 2a plus 1 dB. That's the way I'll write it. Okay, you'll notice I can, well, I'll get there later. Step 1, take d of both sides. Step 2, divide by d of what's in the bottom. D of the variable in the bottom of what we want. And in this case, what is that? Right there, dB. So I'll extend that down over here. It's that dB in this case. Okay, so we just divide by that. We get 2a dA dB plus 2b. Now dB over dB is just 1. Those cancel. We get 2b dA over dB plus 2a plus 1, and dB over dB is again 1. So that's step 1 is by far the hardest step here. Step 3, bring all terms with what we want to one side. And everything else to the other side. So the two terms with dA dB, I'm just going to bring to the left. 2a dA dB minus 2b dA dB equals negative 2b plus 2 a plus 1. So I've just separated the side with dA dB from the side without. Step 4 is factor out what we want to solve for. And then you divide by the rest. So if we factor out dA dB, factor that out, dA dB, we get 2a minus 2b equals, I'm going to rewrite this as 2a minus 2b plus 1. Then if I divide by the rest, that's really me dividing by this 2a minus 2b. Divide everything over there by 2a minus 2b. And so this term actually cancels. And remember, when things cancel, I swear if you guys forget this, remember. There you go, I fixed it. When things cancel in fractions, they become 1. Just keep that in mind. So that's what's actually going on here. So this is dA over dB equals 1 plus 1 divided by a minus b. There's a 2 there as well, I think. No, there is not, because this 2, that's my bad. This is a 2 right here because of that. The 2 has to distribute, of course. So it's 1 over a minus b because I've just canceled some 2's. That's why. Okay, so this is the answer the exam gives. Great. No simplifying to help you here. Put that in parentheses. So there's some times where it just doesn't work. You just kind of have to try, and you might be able to simplify it, and other times you might not. So that's just the way this problem worked out. All right. Let's do problem 4. I made it a bit easier than that really fun Dr. Fauci problem from last week. I had too much fun writing that. I would love to write another one like that, but we'll see if you get one on the final. This is still tricky. It says, at which x value does the shortest line segment between the curve f of x equals x minus 2 squared minus 1/2 and the origin exists. So the shortest line segment is equivalent to the shortest distance. At which x value? AKA shortest distance between the two. Least, big word there, least distance between the two. F of x, and really I should say this as between the points x comma f of x and 0 comma 0. The least distance. So this should give us a huge clue as to how to solve this problem. This is an optimization problem. Involving the distance formula. Now, for those of you who don't remember the distance formula, distance between 2 points, x0, y0, and x1, y1, equals the square root of x. We normally write it a different way. Instead of doing zeros and ones, people normally do ones and twos, so I want to jog your memory with that better. So the distance between x1, y1, and x2, y2 is x2 minus x1 squared plus y2 minus y1 squared. This is alternatively the Pythagorean theorem. The Pythagorean theorem, since if I have 2 points, x1, y1, and another point, x2, y2, then what can I do? I can draw a triangle that looks like this. It's a right triangle. It has side lengths x2 minus x1, side length y2 minus y1, and d up here. Put those in different colors. That's important. So d, y2 minus y1. Put d in a different color. So those are the lengths there. And of course, if you perform the Pythagorean theorem on this, then you would get exactly the distance formula I gave above. So if we apply the distance formula here, right, this is an optimization problem, so you guys better take a derivative, set it equal to 0, and solve for x. We apply the distance formula here. So really this distance just depends on x, and x2 minus x1 is x minus 0 squared, plus y2 minus y1 is f0 squared. So this is like d of x, f of x, comma 0, 0 equals that, right? But it's really just a function of x. This is really just the square root of x squared plus f of x squared. And I want to optimize this. So, ... all caps, take a derivative. Set it equal to 0. Can't not have 2 in caps. Solve for x. There you go. All right, let's do it then. I'm going to rewrite it like d of x is x squared plus, now f of x squared, f of x I defined all the way at the top here. Bring it in yellow all the way down. Oh, I don't want it in that yellow. Crayon yellow. All the way down here. That f of x. Is x minus 2 squared minus 1/2. And that whole thing is squared now, and the whole thing is to the 1/2 power. So no, I didn't give you guys an easy problem, but it works. It does work. All right, let's see what we can do here. I'll tell you what you can't do first, because somebody's thinking about doing this and it's wrong. You cannot just distribute the 1/2 power to everything. The 1/2 power, I should say. That's not how this works. Really, that's not how they work. So definitely don't do that. You're not going to get the right answer. Yeah, you just basically simplify it as best you can. The 1/2 power is going to stay where it is. This is x squared plus on the inside here. I'm going to do this piece first. So I'm gonna do the squaring piece first, the outside squaring piece first. So outside squaring piece is going to give me, it's going to give me x, or I'll do the inside squaring piece first. The inside squaring piece first gives me x minus x minus 4x. Boy, I'm struggling there. X squared minus 4x plus 4 minus 1/2, and that piece is squared to the 1/2 power. Then I get x squared. Now I can square this big piece. Well, I'll rewrite it like this. X squared minus 4x. 4 minus 1/2 is going to be 9/2. Sorry, 7/2. I can add. Give me x squared plus, now I'm going to square that whole term. It's going to give me x to the 4th minus 4x cubed plus 7/2 x squared. And then it's going to give me, so much work, minus 4x cubed plus 16x squared. I'm foiling this out in my head. Minus 14x, and then we're going to go plus 49/4. That's something that your calculator can do for you if you have it. And so what does this actually simplify to on the inside? It's x to the 4th minus 4x cubed. Sorry, minus 8x cubed, because I have 2 of those. And then I have a 16x squared, another x squared, so 17x squared, plus 7/2 x squared. So how many halves is that? 17 times 2 plus 7 is 41. 41/2 x squared. And then I have minus 14x plus 49/4. Oh, I'm missing some terms here. You guys, I've written too hard of a problem. It's okay. The exam won't be quite as hard. 49/4 we have. So what I was actually doing here was I was foiling these piece by piece. This is plus 7/2 x squared minus 14x plus 49/4. Okay, there's actually the end of it. And so these are all wrong. There's a reason why I give you such hard problems on these exams, so that come the final you don't hate me. Okay, so x cubed, we got that right. This is 8x cubed, but the x squared terms, we now have 7/2. So we actually have 7 plus 17. We have 24x squared minus 28x plus 49/4 to the 1/2 power. And now we can finally take a derivative. So simplified, so we can take a derivative. And now this derivative, it's ugly, but it's not impossible because it's just a chain rule. So 1/2, keep the inside the same. to the minus 1/2 here. So this is derivative outside, leave the inside the same, part of chain rule. And then we have a multiply by the derivative of the inside part. So the derivative of the inside is 4x cubed minus 24x squared plus 48x minus 28. Here's the multiply by the derivative of the inside part. And then in the statement of the problem, I'm going to write this down here. In the statement of the problem, I say just plug the x value I give in the answer into the derivative and show it 0. So the x value I give says a, x equals 1. So plug this in. Into d prime to get d prime of 1 equals, so I put that in quotes, right? That's the answer that I gave. D prime of 1 equals 1/2. 1/2. This is 1 minus 8 plus 24 minus 28 plus 49/4 to the minus 1/2 power times 4 minus 24 plus 48 minus 28. And if you actually calculate this out, what does this give? Well, that gives 16, negative 12 plus 1 is negative 11. So that gives a positive 5/4. This gives 5/4 to the negative 1/2. But this gives 0. So we end up with d of 1 is 1/2 times 5/4 to the negative 1/2 times 0. And of course then, that's 0. Yay. So in some sense, this is the equivalent. The equivalent of setting equal to 0 and solving for x. In this case, solving for x is pretty hard, and I chose the numbers so that it would work for x to be equal to 1, and it does. So that's actually what we want to do. So since that's 0, then we're done. Technically we just say that 1 comma f of 1, which is 1 comma. You'll remember what f was. It was x minus 2 squared, so negative 1 squared is 1 minus 1/2, 1 comma 1/2 is the closest point to 0, to the origin. Also what the exam gives, right? Oh. Yes. I actually ask for the length of the line segment too. Length of line segment. This was to check that you got D correct, the distance. You can plug this in. This is 1 squared plus 1/2 squared. Gives you the root 5 over 4, which is also root 5 over 2. Answer exam gives. So yeah, it was a tough one algebraically. And don't worry, I'm giving you tough problems so that the final seems a bit easier than what you've seen so far. But anyway, there you go. There's day 1 of this week's review. Please email me with any and all questions, and I guess I'll see you tomorrow. Bye.